Hello viewers, welcome to the section Developing GUI Application using Layout. In this section we will learn about writing a GUI application with a horizontal layout, writing a GUI application with a vertical layout, writing a GUI application with a box layout, and writing a GUI application with a grid layout. Now we move on to the video writing a GUI application with a horizontal layout. In this video we will learn to create 3 buttons and create a horizontal box layout. Qt is a cross-platform application framework, hence it supports concepts such as layouts for developing applications that look consistent in all platforms, irrespective of the different screen resolutions. Layouts come in different flavors. This helps a developer design a professional-looking HMI GUI by organizing various widgets within a window or dialog. Layouts differ in the way they arrange their child widgets. While one arranges its child widgets in a horizontal fashion, another will arrange them in a vertical or grid fashion. Let's write a Qt application that has a couple of buttons in the dialog. We will now see the game plan. First, we will create a single instance of QApplication. Then we will create a custom dialog by inheriting QDialog. After that, we will create 3 buttons and create a horizontal box layout. Further, we will add the 3 buttons to the invisible horizontal box layout and set the horizontal box layout's instance as our dialog's layout. Finally, we will show the dialog and start the event loop on QApplication. Open the Atom editor and you can see that we have 3 files in ex1 folder. First, we will see mydialog.h file. It is important that we follow clean code practices so that our code is easy to understand and can be maintained by anyone. This is our code. We are going to understand this block of code in a modular fashion. We declare the dialog in a header file called mydlg.h. Then we define the dialog in the source file called mydlg.cpp and use mydlg.cpp in main.cpp that has the main function. This is just an overview. Let's discuss in detail about mydlg.h. One last suggestion. Wouldn't it be easy for others to locate the dialog class if the name of the file and the name of the class were similar? I can hear you say, yes, all set. We declared a class with the name mydlg. It inherits QDialog class. Then we have 3 buttons, 1 layout, and a constructor. Now we will discuss about mydlg.cpp. First we include mydlg.h. Then we defined a constructor that is mydlg. In this box layout line of code, we instantiated the layout. After that, we instantiated our 3 buttons. In lines 27 to 29, we added 3 buttons to the layout. In line number 31, we associated the layout to our dialog. That's all it takes. Next, we will look at main.cpp. We first defined our main function, which creates an instance of QApplication. Then we created our custom dialog instance and displayed the dialog. Finally, at line 27, we started the event loop so that mydlg could respond to user interactions. Let's build and execute our project. Go to our terminal and run the qmake project command. This will create our x1 profile. Then run qmake command. This generates a make file. Before running the make utility command, we have to make a small change in our ex1.profile. Go back to the Atom editor and click on the ex1.profile. After the include path line of code, we have to add a line that is Qt plus equals widgets. Let's go back to our terminal and run the make command. As you can see, we have successfully built our program. Let's execute our Qt application using the / command. Here you can see that we have successfully obtained our 3 buttons. Actually, you can try playing with the dialog to understand the horizontal layout better. First, stretch the dialog horizontally and notice all the buttons' width increase. Then see whether you can reduce the dialog's width to notice all the buttons' width decrease. That's the job of any layout manager. A layout manager arranges widgets and retrieves the size of the window and divides the height and width equally among all its child widgets. Layout managers keep notifying all their child widgets about any resize events. However, it is up to the respective child widget to decide whether they want to resize themselves or ignore the layout resize signals. To check this behavior, try stretching out the dialog vertically. As you increase the height of the dialog's height should increase. but the buttons will not increase their height. This is because every Qt widget has its own preferred size policy. As per their size policy, they may respond or ignore certain layout resize signals. If you want the buttons to stretch vertically as well, QPushButton offers a way to get this done. In fact, QPushButton extends from QWidget just like any other widget. For that, we need to make some changes in our code. Let's go back to our Atom editor and click on the mydlg.cpp file. After line number 25, we will add 3 lines of code. The setSizePolicy method comes to QPushButton from its base class, that is QWidget. The first parameter, QSizePolicy expanding, refers to the horizontal policy, and the second parameter refers to the vertical policy. With these highlighted lines of code, we set size policy to all our 3 buttons. After line number 37, we will set the window title name as horizontal layout within the constructor of mydlg to keep our main function compact and clean. Make sure you have built your project using the make utility before launching your application. Let's go to our terminal. First, close this application. Then, clear this screen using the reset command. Now run the make command. We have successfully built our project. Let's run the binary executable file using the / command. As you can see, we have obtained the application with the title name as Horizontal Box Layout. So when we stretch vertically, our buttons are able to stretch vertically. In this video, we learned to write a GUI application with a horizontal layout.